Hello, we are going to review chemical formula writing for ionic compounds. So this is part one of writing formulas for ionic compounds. Okay, to write formulas for compounds, you're going to need your test periodic table. You're going to need to have memorized your polyatomic ion list, or at least have it handy to look at. And you'll need to make sure that you have committed to memory the following group charges: Group 1A plus 1, Group 2A plus 2, Group 5A nonmetals, -3, Group 6A nonmetals, -2, and Group 7A nonmetals, -1. Remember that we use a test periodic table that looks a bit like this, where we have a reference to certain transition metal ions on top, but we don't have our individual group numbers marked. Okay, so it could be handy for you to go ahead, if you have lost track of your periodic table, to go ahead and on your periodic table write in the group charges for groups 1A, 2A, 3A through 8A. All right, in general, when you're writing a formula, when given a chemical name for an ionic compound, okay, the rules are as follows. Read the name. Use your periodic table to look up the charges for the ions, performed ion crisscross to determine subscripts. To write the formula, write the cation or metal symbol first. The subscript on the cation is the charge number of the anion. Then write the anion or nonmetal symbol next. If the anion is polyatomic, keep the symbol in parentheses. The subscript on the anion is the charge number of the cation. Once you do that crisscross, if the subscripts are multiples, then you would reduce to lowest proportion. Okay, so here is a schematic of the ion crisscross. Let's pretend that we have a metal cation, which I'm going to symbolize with the symbol C, and a non-metal anion, which I'm going to symbolize with the letter A. The cation C has a charge of positive X. The anion has a charge of -Y. If I wanted to write a formula with this single metal and single nonmetal cation and anion, I would write the cation symbol first and give it the subscript that is the charge number of the anion, and vice versa. That's where the crisscross would come in. So the formula would be CXAY. Now, this is an example of a schematic of an ion crisscross using a polyatomic ion. Okay, in this particular example, my cation is monoatomic, or made up of a single metal with a positive X charge, but my anion is polyatomic. I know it's polyatomic because it has multiple elements encased or enclosed in parentheses. The charge of my anion, in this case not necessarily a nonmetal, but a polyatomic ion, is AO4 to the -Y power. If I do the ion crisscross, the subscript on the cation will be the charge number of the anion, and the subscript on the anion will be the charge number on the cation. So Y would crisscross and be the subscript on C, and X would crisscross and be the subscript on the outside of the parentheses, AO4. So my formula would be as written: CY parentheses AO4 close parentheses X. And this little X would distribute by multiplication to the subscripts on the inside of the formula. So you would actually have X number of A's and 4X O's. Okay, so let's write an example. Write the formula for magnesium phosphide. Well, the first thing you would have to do is to look up the charges for both magnesium and phosphorus from your periodic table. Magnesium is a member of group 2A with a +2 charge. Phosphorus is a member of group 5A with a -3 charge. Magnesium and phosphorus's formulas are as follows. Now, if I were to do the ion crisscross, the subscript on magnesium would be the charge number after the phosphorus. So the subscript 3 would become the subscript on magnesium, The subscript on phosphorus would come from the 2 from the magnesium. So I would crisscross. The resulting formula would be Mg3P2. Mg3P2. Now, switching gears, if we were going to write the formula for the formula strontium phosphate, the first thing we would want to do is to look up the charges for each ion. We would want to keep the polyatomic ion, in this case phosphate, its formula in parentheses. Okay, so my 2 ions are Sr positive 2 and parentheses PO4, close parentheses negative 3. I want to keep all the numbers and letters inside the parentheses exactly the same, making no changes. So I am still going to use the charge number on the anion as the subscript on the cation and vice versa. So when I crisscross here, my formula will be Sr3 parentheses PO4 close parentheses 2. And that 2 subscript applies on the outside of the parentheses. So if I were going back and counting how many strontiums and phosphoruses and oxygens are in this formula, it would have 3 strontiums, 2 phosphoruses, and 8 oxygens, because that 2 would distribute by multiplication. So there's really not much difference. We're still doing ion crisscross. We haven't really changed that. Let's try another formula that uses a polyatomic ion. Only this time, the polyatomic ion is the cation instead of the anion. Again, you would have to look up the charges for both ions. Ammonium's formula is NH4 positive 1 and O negative 2. We're going to perform the ion crisscross, and you should get the formula NH4 parentheses 2O. In this case, the subscripts are in lowest proportion because there would be an understood subscript of 1 on the oxygen, and that wouldn't reduce. Okay, so that is ionic formula writing.